Rashmita. Today I'll be presenting my machine learning project titled Machine Learning Based Student Performance Prediction System. This project focuses on predicting academic risk among students using artificial intelligence and data analytics so that teachers and institutions can provide support earlier and improve student outcomes. These are the contents of the PPT which I'll explain as I go. The first, which is to understand the context, objectives, and problem statement. The problem I selected is the late identification of academically struggling students. In many educational institutions, students are only identified after failing exams or showing serious academic decline. Teachers often have to manually monitor a large number of students, which is time consuming and difficult. Because of this delay, intervention happens too late, increasing stress, poor academic performance, and even dropout rates. This is a strong opportunity for machine learning because it satisfies three important criteria. First, it is a prediction problem since student performance can be predicted using historical data. Second, educational institutions already collect large amounts of useful data such as attendance records, grades, assignments, and online learning activities. Third, identifying struggling students is a repetitive process that machine learning can automate and improve efficiently. Then we'll talk about research framework and data insights. The main objective of this project is to predict student risk levels early so teachers can take action before academic performance becomes worse. The project also aims to improve educational outcomes and support teacher decision making using data driven insights. Some important research questions include identifying which factors most strongly affect student performance, determining which machine learning model performs best, and understanding how teachers can effectively use these predictions. These model uses multiple sources of educational data to make predictions. These include academic records, assignment submission, quiz, and exam scores, LMS activity logs, and student demographic information. Using this feature, the model analyzes student behavior, engagement patterns, and historical academic performance to classify students into different risk categories. Then we'll talk about the model development and evaluation along with what would the success, how the success would be measured. Success in this project can be measured using both business and technical metrics. Business metrics include reduced dropout rates, improved pass percentage, better student retention, and faster academic intervention. Technical metrics focus on evaluating the model itself and include accuracy, precision, recall, and expense score. The purpose solution is a supervised machine learning classification system. The workflow begins with collecting and pre-processing educational data, which is then used to train machine learning models. Possible algorithms can include logistic regression, decision trees, random forest, and gradient boosting. This system finally predicts whether a student is at risk or not at risk, helping teachers make informed decisions. To validate the solution, historical student data would first be collected, then be prepared. Then an initial machine learning model would be trained and evaluated using test datasets. After this, the system could be piloted, tested with teachers in a real educational environment. Based on feedback and prediction performance, the model would be improved iteratively. For system design, I selected a batch prediction approach with cloud deployment and a human in the loop review process where teachers evaluate predictions before action is taken. There are several risks that can appear when deploying this model in production. Data drift may occur if student behavior changes over time. Concept drift may happen if the factors affecting academic performance evolve in the future. There may also be bias in predictions if the training data is unbalanced. Incomplete student records and privacy concerns are additional changes. To address these issues, continuous monitoring, regular retraining, and ethical data handling practices are important. In conclusion, machine learning can play an important role in improving educational system by identifying struggling students earlier and enabling timely intervention. This can improve academic performance, reduce dropout rates, and support teachers with data-driven decision making. Thank you.